Alrighty, I don't care if it doesn't work. Let's go. Okay, welcome back to Free Read Fridays. I'm your intrepid, long-suffering narrator, Fragath, and today we're going to read more selections from the June 1945 issue of Astounding Science Fiction. Apologize for the late start. It's technical issues. I don't know why they insist on happening on the one day I don't want them to occur, but that's, of course, when they happen. Whatever. We're here now. So first up are two articles, scientific articles, not science fiction. Think of it as a 1945 era time capsule of the understanding of first how meteors and meteorites burn up uh, in Earth's atmosphere, and one on astronomy, specifically as it pertains to dating stellar explosions, novas, in other words. After that, we have an actual short story in the form of The Ethical Equations by Murray Leinster, if I'm pronouncing that correctly. I've never heard his name spoken aloud. I have read a bunch of Murray's work before. He's pretty good. Um, Tends to be kind of lighthearted, I guess. After this, I think we'll only have like one more installment of this particular magazine, and then I can move to the one or at most two streams of prep work that I'll be doing to set everybody up nicely for Peter Watts's Echopraxia, ideally in time for Halloween, if not November, or at least October. Um, it's going to take me a little longer to get through that than Blind Sight, I think. I believe it's a little longer. Um, I'm in the process of rereading the book right now, so I'm like, this is going to be good. I have ideas. But for the lead in to it, I'm going to be doing the plan starting off initially before I start reading this. Um, There's a short story that ties in reasonably well, and an actual presentation that ties in very well to both Blind Sight. It was done for Blind Sight, but it ties into this even more pointedly. It has some teeth, if you will. And if you know what I mean, you know what I mean. If you don't know what I mean, well, you'll find out. So depending on how all that goes, I'm planning ahead. I'm actually planning ahead. What a crazy concept. Okay, so down to the matter at hand. The first article that we have here, which is only one page, it's short, is called Not Friction by Fred Nash, who tells us, we've been told so often and so authoritatively that meteorites are consumed by air friction in falling through the atmosphere, that we accept, without thinking, the truth of this statement. Since any heat generated in the gas by friction would be external to a slowly changing boundary layer, it would be carried away without materially affecting the meteorite. The true explanation will be found in a consideration of the dynamic theory of gases with respect to the velocity of fall of the meteorite. The theory of gases requires that the temperature of the gas be proportional to the square of the molecular velocity in the gas as long as it follows the laws of Boyle and Charles. That is, as long as it remains a gas of unchanged chemical and physical properties. To escape from, in front of the meteorite, the gas molecules must have a velocity of at least approximately that of the meteorite. This velocity is achieved by compression, but with the velocity there is always heat. Since the velocity of the meteorite, and consequently the molecular velocity of the gas, is enormous with respect to the ordinary molecular velocity, the gas will be hot. Just how hot can the calculated Just how hot can be calculated from the temperature-velocity relation. A meteorite cannot reach Earth at less than Earth's escape velocity of 11,000 meters per second. A more probable velocity is the solar system escape velocity of 80,000 meters per second. If 20,000 meters is assumed as a probable minimum velocity, the temperature works out to be 540,000 degrees Kelvin. This fantastic temperature is, of course, not reached as changes in the gas are at mouth. This fantastic temperature is, of course, not reached as changes in the gas at far lower temperatures cause deviations from the relatively simple law cited. But it is enough to show that it is not friction, but compression that causes the heat. Compression enough to give the molecules velocity to get out of the way of the meteorite, get out of the way, or get blasted into radiation. Calculations on an energy basis indicate that an average size slow meteorite radiates at about the same rate as the sun. I guess falling through the atmosphere is what he's referring to. On this basis, the temperature is about 6,000 degrees Kelvin, which is still hot, and probably very close to the correct value. The temperature of the gas piled up in front of a large, fast meteorite would be much hotter. Um, Seeing as how I don't have any of the figures required in front of me, I can't tell you how true any of this is. I'm going to go to a quick google.com. Kelvin to Celsius calculator. Wrong button. Oh, there we go. Kelvin. So 0 Kelvin is negative minus 273.15 Celsius, which is of course absolute zero, which you basically can't ever have. Which would be, ooh, that's hot. Let's try 6,000 Kelvin. What is that? 5,5726.27 Celsius from 6,000 Kelvin. Is Kelvin plus 273? What? Okay. So temperature of the surface of the sun. Temperature of the surface of the sun is 5,700. Yeah, okay, so he's about right. It's around 6K Kelvin, which is to say, freaking hot. What causes meteorites to burn up? Meteors burn up when they hit the Earth's atmosphere. Why doesn't the space shuttle? Okay, so he's right. It is because of compression. A meteor moving through the vacuum of space typically travels at speeds reaching tens of thousands of miles per hour. When the meteor hits the atmosphere, the air in front of it compresses incredibly quickly. When a gas is compressed, its temperature rises. This causes the meteor to heat up so much that it glows. The air burns the meteor until there is nothing left. Re-entry temperatures can reach as high as 3,000 degrees Fahrenheit, which is 1650 degrees Celsius. This then goes into why our good friend the space shuttle doesn't burn up coming in. Ablative technology, insulating tile technology, and of course it's actually, aerodynamic for starters. And it's not moving so damn fast, which helps. Please go back to the article I was looking for before. Here we go. See, then this article says it's friction as well, but I suppose it's because of it is friction after a sort, but it's also, I believe he's right. In any case. All right, now cosmic explosion. Cosmic explosion. Prediction, past tense, by R.S. Richardson. While not strictly prediction, the astronomer's job in trying to determine what happened 1,000 years from now is just about equally hard, whether it's plus 1,000 or minus 1,000. And when the work is being done with an object so unique as the Crab Nebula, it approaches the impossible. Photographs in the article are from Mount Wilson Observatory, which I think might still be active. I've heard the name before. I might also be dating myself. All right, one sec. If there is one thing astronomers can do really well, it is to predict. Undoubtedly, one of the main reasons why astronomers have always had a certain fascination for the public is because of this seemingly uncanny ability to foretell the future. Of course, anybody can make predictions. Lots of people do. The trouble is, their efforts are so seldom more successful than would be expected from the laws of chance. But when you read in the American Ephemeris that there will be a total eclipse of the sun visible from Rybinsk, USSR on July 9th, 1945, beginning at 14 hours, 19 minutes, 56.8 seconds Greenwich Civil Time, then you know that the Rybinskians can get a piece of smoked glass ready for use on that date with absolute assurance the event will come off as scheduled. To the uninitiated, it looks like witchcraft, and many an astronomer has been burnt at the stake because the authorities were convinced that it was witchcraft. Did it ever occur to you that the ability to predict events in the past may be just as important and even more difficult than in the future? You may object.
Why, that is easy. An event in the past has already happened. We know what lies in the time stream behind us.
But do we? All we really know about the past is contained in the few records that remain with us in the present. We can be sure the future will eventually arrive, but the past is but the past is forever receding into the distance, growing more remote and hazy with the passage of every second. To predict an event that lies buried back 1,000 years and then be able to prove your prediction is correct requires some really expert prognosticating. Sorry. Trying to predict the origin of things is naturally nothing new for astronomers. But usually they aim to go back far enough, say a couple of billion years, so there is no danger of anyone checking up on them too closely. Recently, however, astronomers have done some heavy predicting that goes back in time only to the vicinity of the Battle of Hastings, an era which is growing, a trifle dim, but is still sufficiently close to be in fairly good focus. So I'm going to read the subtext here because there's a paragraph break. On page 99 is a photograph of the Crab Nebula taken on panchromatic film, the blue, green, and yellowish light. This is in black and white, I'm afraid, because of the microfilm copying reproduction of it. Plate above was exposed to the orange-red portion of the spectrum, filaments clearer, center dimmer. If it were predicting the positions of the planets or something of that sort, there would be nothing to it. We can run the solar system backwards as easily as we can run it forward. Foretelling the past or future on the basis of the law of gravitation is hardly more in the nature of a prediction than winding or unwinding a reel of motion picture film. But in this case, astronomers were trying to make a prediction which did not admit of precise calculation. They were somewhat in the position of a meteorologist who tries to predict the temperature for Medicine Hat on January 1st with nothing to guide him but the weather maps for January 28th and 30th. Still further down, this plate exposed. Oh no, I'll do that later. Sorry. The astronomers' problem was this. They had found what was believed to be the remnants of an exploding star. They had measured the rate at which it was still exploding.
From the measured rate of expansion, they could predict when the explosion occurred. But could they prove it? That was the question they were asking 20 years ago. Today, they feel closer to the answer than ever before. Let us see the reason why. So this is the sub caption for the this is the caption for the picture. Still further down, this plate exposed in the extreme red between 6,300 and 6,700 angstroms shows great detail in the outer portion. The constellation of Taurus the Bull is one of those regions that contains a treasury of celestial wonders, with the Pleiades, Hyades, Aldebaran, etc. Taurus also contains one of the weirdest objects in the whole sky, a thing called the Crab Nebula. The name is misleading, for it neither resembles a crab nor is allied with the typical gaseous nebulae. But the designation is now much too firmly entrenched in the literature ever to be dislodged, and will probably be perpetuated on down through the centuries along with the seas on the moon and the canals of Mars. Who discovered the Crab Nebula will never be known. Like the planet Neptune, it seems to have been discovered several times before becoming officially fixed in the sky. As nearly as we can tell, it was first sighted in 1731 by an amateur, an English physician named John Bevis, whose hobby was astronomy. Could be Bevis, but unfortunately I've already read it as Bevis. I apologize. The greatly increased contrast and detail shown in the far red is lost again in this infrared exposure in the regions 7,200 to 8,000 angstroms. I see where they're going with this. I'm going to assume they'll explain it in the article. I've only skimmed it. I haven't read it in detail. This is all new to me. Um, the ideas therein are not, but the article itself is. In 1758, it was discovered again by Messer. Messier? While looking at his usual occupation, while at his usual occupation of looking for comets. Messier, it will be recalled, was the indefatigable comet hunter whom Louis XV dubbed the Ferret of the Skies. One of the most annoying features about comet hunting is making sure you have really found a comet, and not a nebula or star cluster. For his own convenience, Messier made a catalogue of 100 of these fuzzy objects which closely resemble the average telescopic comet. Messier took vast pride in the fact that he discovered 20 comets with a 2-inch telescope. But he would have been forgotten long ago if it were not for his catalogue. For today, these 100 objects are still designated by the number Messier gave them. For example, the star cluster in Hercules is Messier 13. The Great Nebula in Andromeda is Messier 31, and the Crab Nebula had the honor of being Messier 1, the first object in the first important astronomical catalogue of nebulae. Many a young astronomer has become excited over a cometary-looking body which he picks up in the course of his regular work. His first impulse is to telegraph the news to the Harvard College Observatory, which acts as the clearinghouse for astronomical discoveries. Then he hesitates. Perhaps he had better check to see if a nebula or cluster is in that region. And sure enough, to his chagrin, he finds it is only Messier 51, to which a footnote is appended, often mistaken for comet. Sadder and wiser, he returns to his telescope with the realization that his name is now added to the long list of suckers before him who thought they had found something. Even after Messier's catalogue was published, astronomers kept on discovering the Crab Nebula. The era of discovery finally ended in 1844, when Lord Rosse made a drawing of the nebula as seen through the 6-foot reflector erected upon his estate at Parsonstown, Ireland. This telescope was the giant of its day, and can still probably claim the distinction of being the unwieldiest ever pointed at the sky, which is saying a good deal. The tube swung up and down between two parallel walls of masonry from which it was suspended by chains. This limited the time you could observe a star to the few minutes it was on your meridian. If you failed to catch it when it went directly north or south, you had to wait until the next night. Apparently, there was no clock drive, the telescope being kept on the star by the old tried and true system of moving it by hand. I have just resurrected an old engraving of Lord Rosse's original drawing of the Crab Nebula. The representation is startling, to say the least. With a full appreciation of the difficulties under which observations were made with such an instrument, one cannot but help but suspicion that if his lordship really thought he saw in the sky what he drew on paper, he must have been fortified with some of the Irish whiskey for which that section of the isle is famous. The picture more nearly resembles the body louse, pediculus corporis, under a magnification of 10,000 times, than it does a crab. But it looked like a crab to Lord Ross, and as the Crab Nebula, it has been known for a century. I'm mangling this, and I apologize. Partly it's because the print is faded, and it's kind of hard to read, and partly because I'm reading it dry and my brain hurts. Not until the Crab Nebula came under the searching scrutiny of the photographic plate did astronomers begin to notice anything remarkable about it. But as they became more familiar with the nebulae in general, it began to dawn that here was an object wholly unique, as Lampland of the Lowell Observatory noted in Substance in 1921. In form and in the character of its detail, the Crab Nebula may be said to stand in a class by itself. At first sight, it resembles an oval nebulous mass, like a piece of coarsely woven fabric shot through with loose thread-like filaments, which give it a peculiarly frayed or unravelled aspect along its border. But on closer examination, the nebula is seen to be composed of two parts, an inner brighter mass, in which the structure is very intricate, surrounded by an outer system of fine tentacle-like filaments. As plates began to accumulate, it was only natural for astronomers to compare those taken several years apart in the hope of finding changes in this queer object. The easiest way to do this is by blinking them. That is, by putting them on a machine called a blink comparator, whereby two plates can be viewed alternately through the same eyepiece. Two photographs of the same object on the same scale are adjusted in the machine, so that the fixed stars common to both appear superimposed in the eyepiece. By rapidly switching from a view of one plate to the other, any moving point will seem to jump among the stars, which remain stationary. And the subtitle for the photo is "The vector arrows represent 500 years motion of parts of the Crab Nebula. Projected backward, they indicate the origin at the white dot." Which is right here-ish, I guess. I'm assuming that's the white dot, as opposed to the absolute center of the mass, which is interesting. I assume that means drift. All right. Oh, and I'll read the subtitle for this one here. Another type of nova, a mere ordinary nova, shows an expanding nebulous ring in a few years. These three plates show nova aquilae. Okay. If the photo quality were better, that would be good. I mean the reproduction quality, because it's like a photo of a photo of a photo. No, photo of a microfilm of a magazine, which happens to have a photo in it. Thus, by means of the blink comparator, a faint asteroid can be made to reveal itself by the way it jumps among the fixed star images on two photographs taken a short time apart. It was by blinking the Crab Nebula that Lampland first detected motion among the tangled outer network of filaments. He announced the motion without attempting to measure it exactly. To measure an effect of this kind is a much more difficult job than might be supposed from the plates themselves. Unlike measurements on star images, there are no sharp points on which to see the crosshairs of the eyepiece. Photographs of the stars intended for measurement are made with the shortest exposures possible so that the images are tiny points instead of the blobs they appear on plates taken to exhibit some special object. The best you can do to select the best you can do is to select the sharpest, most conspicuous nebular knots and condensations, and then measure them as honestly as you can. The first exact measurements on the Crab Nebula were made by Duncan in 1921 on two plates taken at Mount Wilson 11.5 years apart. He selected 12 condensations around the edge of the nebula and measured their positions with respect to the nearby fixed stars. The results for the different points varied slightly, as might be anticipated, but, on the whole, the agreement among them was very good. They showed definitely that the mass is not a static thing. Instead, the Crab Nebula is expanding. And the subtitle for the photo is Extreme Left, July 1922, Center, September 1926, Above, August 1931. Now, expanding nebulosity was not altogether unknown at that time. A cloud had already been observed surrounding Nova Persei in 1901 and Nova Aquilae 1918. The rate of expansion around these novae had been measured so accurately that if the dates of the outbursts were unknown, they could have been set approximately by calculating backward to the time when all the outward moving points intersected. What was more natural than to assume that the Crab Nebula was a sort of fossilized explosion, the remnants of a nova that had exploded centuries ago, and because there is nothing to stop particles in space, is still exploding. Just as in the case of Nova Persei and Nova Aquilae, Persei and Aquilae, it should be possible to calculate back to the time when all the outward moving velocity arrows would converge to a point. The point of convergence should mark the position of the exploding star, and the distance through which they were traced backward should give the time since the explosion occurred. When these operations were carried out, the arrows were found to converge near a point occupied by a faint double star at the center of the nebula. The time of the explosion was much more uncertain, but was tentatively set at somewhere around 1100 AD. The next step was to see if anyone had chanced to observe a nova about 800 years ago in the direction of the Crab Nebula. It so happened that the Swedish astronomer Lundmark had just published a list of suspected novae obtained from translations of ancient documents. There was a record of one nova observed by a Chinese in 1054 AD that looked pretty hopeful. The Chinese have contributed relatively little to modern astronomy, but they were certainly on the job in the past. Whether it was an ancient eclipse, a naked eye sunspot, or a bright comet, the Chinese had it. Just dig around long enough among their old manuscripts, and there it is. The world is indebted to the Chinese for two great contributions to civilization: gunpowder and toilet paper. But astronomers owe them a special debt of gratitude for always being around when anything exciting was going on in the heavens. And I will read the subtitle for the photo here. The effect of increasing stellar temperature on the spectrum. At the top are extremely hot stars, at the bottom, cool ones. 1. Sirius. 2. Deneb, 3. Procyon, 4. Marsac, 5. The Sun, 6. Arcturus, 7. Aldebaran, 8. Betelgeuse. Unfortunately, the information which Lundmark had uncovered was not sufficient in itself to identify the nova beyond a reasonable doubt. Like most ancient documents, this one was couched in vague and unfamiliar terms. In addition, there was an uncertainty of about 50 years between the observed and calculated times. Corroboratory evidence from an independent source was required before the identification could be considered established. If astronomers seem unduly conservative in thus withholding judgment, it is because they have had plenty of opportunity to find out how badly people can be in error when it comes to reporting celestial phenomena. Almost every week, a large observatory will receive a letter or telephone call about a strange light or moving star in the heavens. Often such reports can be attributed to a meteor or an airplane. But in many instances, there seems no escape from the conclusion that the individual dreamed he saw something. I once became involved in a long telephone conversation with a man who was wildly excited because he had been seeing the moon all day. He was sure the moon had either gotten clear out of its orbit or strayed badly from the beaten path, and no amount of reasoning would convince him otherwise. Today, after 20 years, new records of old novae have been found, and better measures on the Crab Nebula are available. There can now be no further doubt but that an exceptionally brilliant nova appeared in the constellation of Taurus in June or July of 1054 AD. The latest measures on the Crab Nebula using an interval of 29 years have put the time of explosion at about 1172 AD. Although this makes the discrepancy even greater than originally, the measures are so uncertain that the difference of 118 years is not regarded as excessive. Besides, we have no guarantee that the rate of expansion would remain absolutely constant for 800 years. It is interesting to see how much information can be extracted from the Chinese observations. One observation in particular, relating to the disappearance of the guest star, as the Chinese called it, is of the utmost significance. Originally, this star had become visible in the fifth moon of the first year of the period of Chi Ho, from June 9th to July 8th, 1054, in the eastern heavens, in the Tianquan, near the star Zeta Tauri. It was visible by day, like Venus. Pointed rays shot out from it on all sides. The color was a reddish white. Altogether, it was visible for 23 days. Wow, that's pretty impressive. Obviously, this quotation was made by a Chinaman who was a good observer. He gives us a great deal of valuable information. The two italicized statements are of vital importance, for they enable us to determine the apparent brightness of the nova with high accuracy. The fact that it was as bright as Venus and could be seen in broad daylight tells us at once that its magnitude was at least -4. The faintest naked eye star has an apparent magnitude of 6. The experts, however, are inclined to put more faith in the statement that it was visible in daylight for 23 days. From comparison with the light curves of novae carefully studied in modern times, they feel that one such remained visible to the naked eye for so long probably had a magnitude of at least 5. Is that a minus symbol in front of it, or is it the squiggly about symbol? I can't actually tell. To be able to obtain a relative value for the apparent magnitude of a nova that flared up 800 years ago is really getting somewhere. For by combining this figure with the distance of the Crab Nebula, the astounding fact emerges that not only was the guest star of 1054 AD a nova, but a supernova. And what is more, just about the brightest supernova on record. In order to compare the brightness of supernovae, or any stars for that matter, we must first put them at the standard distance astronomers have adopted for this purpose of 10 parsecs or 33 light years. The magnitude of a star at 10 parsecs is called its absolute magnitude. Until we know the absolute magnitude, we know very little about the true luminosity of a star. The sun looks so bright because it is so near. If the Sun were moved off to the standard distance of 10 parsecs, its magnitude would drop from minus 26.7 down to 5, showing that Sol is just an ordinary dwarf of moderate brightness. Knowing the apparent magnitude of the nova of 1054 AD, we can compute its absolute magnitude as soon as we know the distance, or what now amounts to the same thing, the distance to the Crab Nebula. And as I had occasion to remark in a previous article, astronomers are never at a loss when the distance of a star is concerned. In this case, it is really very simple. Duncan's measures give us the rate of expansion of the nebula in angular units, how long it takes the nebula to expand 1 second of arc, for example. If we knew how many miles corresponded to an expansion of 1 second of arc, the distance could be found on a slide rule immediately. But first we must know the rate of expansion in miles. This seemingly hopeless quantity is readily obtained with that handy instrument, the spectroscope. Doppler's principle tells us that when a source of light is approaching the observer, the rays it emits, spectrum lines, will be shifted to the violet side of their normal position. If receding, the shift is toward the red. Furthermore, the greater the speed of approach or recession, the greater is the shift to the violet or red. If there is any further lingering doubt about whether the Crab Nebula is expanding or not, it would be quickly removed by one look at a photograph of its spectrum. For the lines, instead of being straight, are split into two parts like a bow. At the rim of the nebula, where the particles are at rest, in our line of sight, there is no shift toward the red or violet. But as we go toward the center of the nebula, we begin to get light from both sides of it. From the nearer or approaching side, we get the light that is shifted toward the violet. From the farther or receding side, we get light that is displaced toward the red. As a consequence, a spectrum line, such as the powerful red ray emitted by hydrogen called H alpha, is bowed or lens-shaped. The lines come together at the rim of the nebula and are spread farthest apart at the center. And the subtitle for the photo diagram here is Getting the spectrum of a nebula, or of a nebula-wrapped star, is extremely difficult. The comet-like, almost featureless blurs are the nebular spectra. The lines at the top and bottom of each are for comparison. The figures indicate the direction of the spectroscope slit in each exposure. Cool. By measuring the maximum separation between the red and violet components of the bow-shaped line, we can get the speed in miles at which the nebula is expanding. Measurements on the various spectrum lines give a mean velocity of expansion of 2,300,000 miles per hour. And there's a footnote here. It is interesting to note that the spectroscope alone does not tell us whether the nebula is expanding or contracting, but from Duncan's work we know it must be a motion of expansion. Mostly because, it's expanded over the course of hundreds of years. Using the best value for the rate of angular expansion, we get a distance of 4,100 light years. Knowing the distance, we can obtain the dimensions of the nebula. It is a football-shaped mass about 6 light years long and 3.5 light years wide. At a distance of 4,100 light years and an apparent magnitude of -5, the absolute magnitude of the supernova at maximum was -16.5, which is very nearly the highest ever measured for any supernova, either inside our galaxy or without. If the supernova of 1054 AD had been as near as Alpha Centauri, it would have lit up the night sky with a brightness equal to that of 3,700 full moons. We'd also probably be friggin' baked. Like, atmosphere or no, that'd be pretty damn proximate. Because Alpha Centauri is what, like 1 light year out? And this thing is at this point how, in 1054. Actually, no, it wasn't 1054. It was now. Mass about 6 light years long and 3.5 light years wide. It's big, in other words. It's big. I mean, it would be past us by now, but I would worry about incoming stellar radiation. Then again, if the sun were in the way at the time, but it's whatever. The question that arises to bother us now is, what has kept the Crab Nebula shining these 800 years? A flimsy cloud of gas thousands of times more rarefied than the air we breathe cannot be just on fire out there in the cold of space, as a student of mine once maintained. Wow, way to call Timothy out, dude. Jeez, harsh. Somewhere on the premises there must be a powerful source of energy supply. We know that the other nebulae in our galaxy are illuminated by the stars embedded within them. If there is no star, there is no nebula in sight. Many dark nebulae are revealed only because there happens to be a bright background of stars behind them. That makes sense. In the case of some nebulae, such as those surrounding the Pleiades, the gas is illuminated simply by reflection, just as a streetlight illuminates the fog around it. The nebula is then the nebula then is the same color as the star that makes it visible. But if the star is hotter than 20,000 Kelvin, it will set the nebula to shining on its own account. In other words, instead of the star doing all the work, as in the pure reflection nebulae, the star feeds energy into the gas, excites it, and forces the nebula to self-luminosity. This is what is happening in the greenish-colored nebulae, such as the one in the Sword of Orion. The Crab Nebula shines in a way that is different from either of these. The inner part, which is responsible for 80% of the total luminosity, emits light of all colors like the atmosphere of a star. There used to be some doubt as to whether this was reflected or emitted light, but there can be no doubt now that it is emitted. The outer system of filaments, however, emits only certain definite rays, such as the red H alpha line of hydrogen, as the greenish colored nebulae do. This may be demonstrated in a striking manner by photography. If the nebula is photographed with a panchromatic plate so that light of all colors registers, we get an image which shows the inner bright mass strongly, but the filaments are relatively weak. But when a red filter and a special color-sensitive emulsion is used so that the range of light is restricted to the region around the red H alpha line emitted by hydrogen, then the filaments come up in strong contrast, while the inner bright mass is much weakened. The Crab Nebula is so bright that it must be excited to shine by an exceedingly hot star. This star should be easy to locate because it should be so blue. There is a faint double There is a faint double near the center of the nebula which has long been under suspicion. Two astronomers at Mount Wilson, Bode and Minkowski, have made a special study of this star working as a team. Their results, which were just recently published, instead of settling anything instead their results, which were just recently published, instead of settling anything, tend rather to show how little we still know about stellar interiors. Bode undertook the task of trying to measure the colors of the two components of the double. This was very difficult, owing to the faintness of the star itself and because it is heavily obscured by the overlying nebulosity. The northern component of the double turned out to be about the color of the sun, so that obviously is not the exciting star. The southern component was found to be white, but not nearly white enough, its color temperature being at the most 20,000 Kelvin, which is disappointingly low. An examination of all the other stars in the vicinity, down to the 20th magnitude, failed to reveal one that was excessively blue. It was very puzzling. How could such an enormous mass of gas keep shining brightly with no visible means of illumination? Well, that reminds me of some people I've known. It was as puzzling as how some people manage to live comfortably without any visible means of support. quite what I was talking about. Despite Bod's negative result, it was hard to abandon the notion that the hotter southern component was somehow the source of energy supply. Perhaps there was something peculiar about the star that failed to show in its color alone. For example, it had been known that stars of class O, sure, let's call it an O, are abnormally yellow, although their spectrum indicates they must be the hottest stars in the sky. But if the color of the star was hard to get, its spectrum was doubly so. The star is covered by nebulosity to such an extent that there is scarcely any contrast left to distinguish between them. The only hope would be to try for a photograph on a night when the air is unusually calm, so that the image of the star is exceptionally hard and sharp. Working at the 100-inch with a special nebular spectrograph, Minkowski was finally able to obtain one satisfactory plate. The exposure was made in such a way that the spectra of both components of the double star were photographed at one shot. The plate showed the northern component to have a spectrum crossed by numerous dark lines, like those in the sun, which agreed with Bod's estimate of its color. The southern component, according to Bod, should have a spectrum containing a few dark lines like those in a white star such as Rigel or Vega. But strangely enough, its spectrum resembled neither that of Rigel nor Vega, nor any other star ever observed, for its spectrum was a blank. There were no lines in its spectrum at all. Now, a cool red star like Betelgeuse has a spectrum choked with long black bands and lines produced by molecules and atoms. A yellow star like the Sun is too hot for the molecular bands, but there are still thousands of dark atomic lines. In white stars like Rigel, most of the atoms are so brightly ionized that practically all of the lines are gone. That is, as we go from cooler to hotter stars, the spectrum keeps thinning out, as it were, until in the very hottest stars, known of spectral class O5, we find only a few lines left of hydrogen and ionized helium. The classification of OO 0, 0, 0-0 has been proposed for hypothetical stars so hot that no lines are left at all. For the first time, it appeared that here was a star of spectral class 0-0. The inference was that it is so infernally hot that no atoms are left in its atmosphere capable of producing a visible absorption line. Yet there still remained the difficulty that Bod's observations showed it was much too yellow to have such a high temperature. Whether this star is the source of luminosity for the Crab Nebula is still unsettled today. But on the tempting assumption that it is the true source, Minkowski has gone ahead and made some calculations, which, if verified, will make this object one of the most startling in all uranology. Uranology. His calculations are based upon quantum mechanical considerations so complex that only the results are reported here. Here we go. Fun times with numbers. The star is a small body with a radius 1/50th that of the Sun, and with a mass about equal to that of the Sun. This makes its average density so high that it must be in the white dwarf class, tiny stars of extremely high density composed of crushed atoms, or degenerate matter, as it is called. The surface temperature of the Sun is 6,000 degrees Kelvin. The surface temperature of the hottest stars is about 30,000 degrees Kelvin. But according to Minkowski, the surface temperature of the star at the center of the Crab Nebula is, hold your breath, 500,000 degrees Kelvin. Even with a radius 1/50th that of the Sun, its total luminosity would be equal to 30,000 suns.
It's a bright little boy.
The best way to gain some conception of the flood of radiation that would blast a planet revolving around such a sun is by comparison with our own system. We can always gain a rough idea of the temperature of the sun's surrounding at any point by calculating the black sphere temperature there. That is, the temperature a black body like a meteorite would have according to the laws of radiation. At the distance of the Earth, the black sphere temperature is 39 degrees Fahrenheit, which is close enough to the temperature of the Earth to serve as a fairly reliable guide to the planetary temperatures in general. What would be the black sphere temperature of a meteorite revolving around a star like the one at the center of the Crab Nebula at the distance of the Earth? The answer is that it would not revolve as a recognizable meteorite very long, because it would be speedily converted into a cloud of gas. Its black sphere temperature would be 50,000 degrees, 50, oh my God, 5,700 degrees Fahrenheit. What is wrong with me? Which is still well above the vaporization point of the most refractory metal. Even at the distance of Pluto, the black sphere temperature would be 925 degrees Fahrenheit. Not until the Earth were removed to a distance of 5 times that of Neptune would the temperature be reduced to that which we are accustomed, which would be somewhere out in the Oort cloud, wouldn't it? Oh yeah, because that's Neptune is how many AUs out? Sorry, quick internet math. Google. Professor Google, tell me how far distance in of Neptune from the sun in AUs. Astronomical units, yes, 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 yes. Neptune is 30 AUs away. So 30 AUs, 5 times 30 is, let's see, distance of the Oort cloud from the sun in AU. About 100,000 astronomical units. So it would be within the Oort um, by quite a bit. What's the thing in between Pluto and the Oort? I don't actually remember. It has been a while. Oh, it'd be out like it's Kuiper Belt, not Oort cloud. Kuiper Belt. Thank you. I have brain. I use brain. I remember astronomy. It's just been way too long. Oort cloud is way out there. It's the Kuiper Belt that I'm thinking of. Okay. Not until the Earth were removed to a distance of 5 times that of Neptune would the temperature be reduced to that which we are accustomed. That'd be like out somewhere deep Kuiper Belt or beyond. It's a ways out. The Earth's atmosphere acts like a color filter that cuts off the ultraviolet light of the sun sharply at wavelength 2900 angstroms. But since the sun only radiates feebly in the violet and ultraviolet, the great bulk of sunshine is able to penetrate on down to the surface. The sun radiates greenish yellow light more intensely than any other. For a star at 500,000 degrees Kelvin, the most intense radiation would be shifted out of the green, beyond the blue and violet, beyond the ultraviolet, clear out into the region of soft X-rays. So much radiation would be in the far ultraviolet that the Earth's atmosphere would allow but 1/10,000th part of it to reach the surface. A lucky thing for us, too. Even with the ozone of the upper atmosphere to protect us, we would still be in grave danger of injury to our eyes and skin. A first glance, the combination of a star 30,000 times as luminous as the sun with white dwarf characteristics seems like a flat contradiction of terms, for the white dwarfs are the feeblest radiators in the sky. But even this anomaly is found to fit into the picture and strengthen rather than weaken the theory. Indeed, the theory was proposed in 1939 by Chandrasekhar at the Paris Conference on White Dwarfs and Novae, 3 years before Minkowski's investigation. According to our present ideas on stellar evolution, a normal star toward the end of its life history is supposed to have contracted until its center, until, oh my God, I can't read, According to our present ideas on stellar evolution, a normal star toward the end of its life history is supposed to have contracted until at its center a dense core of degenerate matter has begun to develop, the first step into the senile white dwarf stage. But Chandrasekhar has shown that if a star exceeds a certain critical mass, about 10 times that of the Sun, it will be unable to develop a degenerate core in the normal manner. Instead, the star will go right on contracting apparently without limit. And we've got a little advertisement blurb here. Don't wait until there isn't an available copy of your favorite magazine. A whole year of reading pleasure, thrills, and chills can be had by just filling in this coupon and sending it to us immediately. Don't wait. Act now. Astounding Science Fiction, 122 East 42nd Street, New York, New York. Enclosed is $2.50. Kindly send me a year's subscription to Astounding Science Fiction. Name, city, address, and state. It is unthinkable, however, that this shrinking process could continue indefinitely without eventually causing some drastic upheaval within the star's interior. Its only hope of salvation from becoming a cosmic fly speck is to get below Chandrasekhar's critical mass value. So, what happens? The star explodes. The surplus mass is sent flying off into space. After which, the remaining mass goes ahead and develops a degenerate core as any normal white dwarf should. Chandrasekhar suggests that this is what happens when we see a supernova. A massive star is getting rid of its surplus matter so that the remainder can collapse into a white dwarf. The mass of the Crab Nebula is estimated to be about equal to 15 suns, and the central star to one sun. This would mean that the explosion of 1054 AD blew away 15/16 of the original star. Minkowski's figures show that at present about 70% of the star's interior is degenerate, the other 30% forming a brilliant atmospheric fringe. If the star is an unfinished white dwarf, the transformation into the completely degenerate state can be expected in the not too distant future. Its luminosity will then sink rapidly from 30,000 suns down to less than 1/100th that of the Sun. But long before this stage is reached, the Crab Nebula will have faded far below the light grasp of our largest telescopes and most sensitive recording devices. The abnormal yellow color of the central star, which Bode found, is naturally explained by Minkowski's results. The correspondence between color and temperature is based upon laws deduced from an ideal the correspondence between color and temperature is based upon laws deduced for an ideal unattainable perfect radiator. No star conforms exactly to these laws, not even a normal one like the Sun, so it is not at all surprising that a half-breed white dwarf deviates widely in this respect. We must remember that our atmosphere allows us to see but 1/10,000th part of the star's light. And just because the chink that does get through to us fails to look as white as it should, we dare to say that the other 9,999 parts are also abnormal. It is like finding the broken toe bone of a dinosaur and reasoning that because one little member is irregular, the whole animal must have been deformed. The end. And that was Prediction, Past Tense by R.S. Richardson, which is a delightful and slightly less dry than I was expecting article on measurement of novae, specifically the Crab Nebula, which isn't a nebula as we've established. So now that we can actually move on with our life, to, the main event, the thing that I've been trying to get towards, we see what appears to be a silhouetted object. I know what it looks like to me. I'll let other people come up with their own guesses. Definitely the illustrator had something on the brain. The Ethical Equations by Murray Leinster. Dedicated, in a way, they were to the proposition that virtue is, not its own reward, but apt to lead to fortuitous concatenations of subsequent events, let's say. Anyway, they did for one man. What the hell? Dedicated in a way, they were, to the proposition that virtue is not its own reward, but apt to lead to fortuitous concatenations of subsequent events, let's say. Anyway, they did for one man. Oh god, this is gonna be fun. Like my brain isn't reading sentences properly right now, and I'm so sorry. All right, sorry about that. I'm just adjusting my chair. I'm settling in for the long haul. The Ethical Equations by Murray Leinster, illustrated by Williams. It is very, very queer. The ethical equations, of course, link conduct with probability and give mathematical proof that certain patterns of conduct increase the probability of certain kinds of coincidences. But nobody ever expected them to have any real practical effect. Elucidation of the laws of chance did not stop gambling, though it did make life insurance practical. The ethical equations weren't expected to be even as useful as that. They were just theories, which seemed unlikely to affect anybody particularly. They were complicated, for one thing. They admitted that the ideal pattern of conduct for one man wasn't the best for another. A politician, for example, has an entirely different code, and properly, than a space patrol man. But still, on at least one occasion, the thing from outer space was 1,500 feet long, and upward of 150 feet through it at its middle section, and well over 200 in a curious bulge like a fish's head at its bow. There were odd, gill-like flaps just back of that bulge, too, and the whole thing looked extraordinarily like a monster, eyeless fish floating in empty space out beyond Jupiter. Yep, that's definitely what I thought it looked like. But it had drifted in from somewhere beyond the sun's gravitational field. Its speed was too great for it to have a closed orbit, and it swung with a slow, inane, purposeless motion about some axis it had established within itself. The little space cruiser edged closer and closer. Freddie Holmes had been a pariah on the Arnina, all the way out from Mars, but he clenched his hands and forgot his misery and the ruin of his career in the excitement of looking at the thing. "No response to signals on any frequency, sir," said the communications officer, formally. "It is not radiating. It has a minute magnetic field. Its surface temperature is just about 4 degrees absolute." The commander of the Arnina said, "Humph." Then he said, "We'll lay alongside." Then he looked at Freddie Holmes and stiffened. "No," he said, "I believe you take over now, Mr. Holmes." Freddie started. He was in a very bad spot, but his excitement had made him oblivious of it for a moment. The undisguised hostility with which he was regarded by the skipper and the others on the bridge brought it back, however. "You take over, Mr. Holmes," repeated the skipper bitterly. "I have orders to that effect. You originally detected this object, and your uncle asked the headquarters that you be given full authority to investigate it. You have that authority. Now, what are you going to do with it?" There was fury in his voice, surpassing even the rasping dislike of the voyage out. He was a lieutenant commander, and he had been instructed to take orders from a junior officer. That was bad enough. But this was humanity's first contact with an extrasolar civilization, and Freddie Holmes, Lieutenant Junior Grade, had been given charge of the matter by pure political pull. Freddie swallowed. I I He swallowed again and said miserably, "Sir, I've tried to explain that I dislike the present setup as much as you possibly can. As much as you possibly can. I wish you would let me put myself under your orders, sir, instead of—"
No! Rasped the commander vengefully. You are in command, Mr. Holmes. Your uncle put on political pressure to arrange it. My orders are to carry out your instructions, not to wet nurse you. If the job is too big for you to handle, this is in your lap. Will you issue orders?
Freddie stiffened. "Very well, sir. It's plainly a ship and apparently a derelict. No crew could come in without using a drive, or allow their ship to swing about aimlessly. You will maintain your present position with relation to it. I'll take a spaceboat and a volunteer, and if you will find me one and look it over." He turned and left the bridge. 2 minutes later he was struggling into a spacesuit when Lieutenant Bridges, also junior grade, came briskly into the spacesuit locker and observed,
I've permission to go with you, Mr. Holmes.
He began to get into another spacesuit. As he pulled it up over his chest, he added blithely,
I'd say this was worth the price of admission.
Freddie did not answer. 3 minutes later the little spaceboat pulled out from the side of the cruiser. Designed for expeditionary work and tool carrying rather than as an escape craft, it was not enclosed. It would carry men in spacesuits with their tools and weapons, and they could breathe from its tanks instead of from their suits, and use its power and use its power and so conserve their own. I'm going to take this entire paragraph from the top. I'm sorry. They're talking about an EVA unit, kind of like that EVA pod that was in 2001: A Space Odyssey, except not. This is actually fairly clever. Freddie did not answer. So I'm sorry, I am taking this from the top of this paragraph because I'm just like, tongue-tied. Freddie did not answer. 3 minutes later, the little spaceboat pulled out from the side of the cruiser. Designed for expeditionary work and tool carrying rather than as an escape craft, it was not enclosed. It would carry men in spacesuits with their tools and weapons, and they could breathe from its tanks instead of from their suits, and use its power and so conserve their own. But it was a strange feeling to sit within its spidery outline and see the great blank sides of the strange object draw near. When the spaceboat actually touched the vast metal wall, it seemed impossible, like the approach to some sorcerer's castle across a monstrous moat of stars. It was real enough, though. The felted rollers touched, and Bridges grunted in satisfaction.
Magnetic. We can anchor to it. Now what?
"We hunt for an entrance port," said Freddie curtly. He added, "Those openings that look like gills are the drive tubes. Their drive's in front instead of the rear. Apparently, they don't use gyros for steering." There's no quotation marks, but I'm assuming that's in his voice. The tiny craft clung to the giant's skin, like a fly on a stranded whale. It moved slowly to the top of the rounded body, and over it, and down on the other side. Presently the cruiser came in sight again as it came up the near side once more.
Nary a port, sir, said Bridges blithely. Do we cut our way in?
Said Freddie slowly. "We have our drive in the rear and our control room in front, so we take on supplies amidships, and that's where we looked. But this ship is driven from the front. Its control room might be amidships. If so, it might load at the stern. Let's see." The little craft crawled to the stern of the monster. Oh, God. Why am I yawning? Jeez. The little craft crawled to the stern of the monster. "There!" said Freddie. It was not an entrance port on any It was not like an entrance port on any vessel in the solar system. It slid aside without hinges. There was an inner door, but it opened just as readily. There was no rush of air, and it was hard to tell if it was intended as an airlock or not. "Air's gone," said Freddie. "It's a derelict, all right. You might bring a blaster, what I what we'll mostly need is light, I think." The magnetic anchors took hold. The metal grip shoes of the spacesuits made loud noises inside the suits as the two of them pushed their way into the interior of the ship. The space cruiser had been able to watch them until now. Now they were gone. The giant enigmatic object, which was so much like a blind fish in empty space, floated on. It swung aimlessly about some inner axis. The thin sunlight out here beyond Jupiter smote upon it harshly. It seemed to hang motionless in mid-space against an all-surrounding background of distant and unwinking stars. The trim space patrol ship hung alertly a mile and a half away. Nothing seemed to happen at all. Freddie was rather pale when he went back to the bridge. The pressure mark on his forehead from the spacesuit helmet was still visible, and he rubbed at it abstractedly. The skipper regarded him with a sort of envious bitterness. After all, any human would envy any other man who had set foot in an alien spaceship. Lieutenant Bridges followed him. For an instant there were no words. Then Bridges saluted briskly.
"Reporting back on board, sir, and returning to watch duty after permitted volunteer activity."
The skipper touched his hat sourly. Bridges departed with a crisp precision. The skipper regarded Freddie with the helpless fury of a senior officer who has been ordered to prove a junior officer a fool, and who has seen the assignment blow up in his face, and that of the superior officers who ordered it. It was an enraging situation. Freddie Holmes, newly commissioned and assigned to the detector station on Luna, which keeps track of asteroids and meteor streams, had discovered a small object coming in over Neptune. Its speed was too high for it to be a regular member of the solar system, so he'd reported it as a visitor and suggested immediate examination. But junior officers are not supposed to make discoveries. It violates tradition, which is a sort of ethical equation in the Space Patrol. So Freddie was slapped down for his presumption. And he slapped back on account of the ethical equations bearing upon scientific discoveries. The first known object to come from beyond the stars ought to be examined. Definitely. So, most unprofessionally for a Space Patrol junior, Freddie raised a stink. The present state of affairs was the result. He had an uncle who was a prominent politician. That uncle went before the Space Patrol Board and pointed out smoothly that his nephew's discovery was important. He demonstrated with mathematical precision that the patrol was being ridiculous in ignoring a significant discovery simply because a junior officer had made it. And the board, seething at outside interference, ordered Freddie to be taken to the object he had detected, given absolute command of the space cruiser which had taken him there, and directed to make the examination he had suggested. By all the laws of probability, he would have to report that the hunk of matter from beyond the solar system was just like hunks of matter in it. And then the board would pin back both his and his uncle's ears with a vengeance. But now the hunk of matter turned out to be a fish-shaped artifact from an alien civilization. It turned out to be important. So the situation was one to make anybody steeped in patrol tradition grind his teeth. "The thing, sir," said Freddie evenly, "is a spaceship. It is driven by atomic engines shooting blasts sternward from somewhere near the bow. Apparently they steer only by hand. Apparently, too, there was a blow-up in the engine room, and they lost most of their fuel out the tube vents. After that, the ship was helpless, though they patched up the engines after a fashion. It is possible to calculate that in its practically free fall to the sun, it's been in its present state for a couple of thousand years."
"I take it, then," said the skipper with fine irony, "that there are no survivors of the crew."
It presents several problems, sir, said Freddie evenly, and that's one of them. He was rather pale. The ship is empty of air, but her tanks are full. Storage spaces containing what look like supplies are only partly emptied. The crew did not starve or suffocate. The ship simply lost most of her fuel. So it looks like they prepared the ship to endure an indefinite amount of floating about in free space, and he hesitated. Then it looks like they went into suspended animation. They're all on board, in transparent cases that have machinery attached. Maybe they thought they'd be picked up by sister ships sooner or later. The skipper blinked.
Suspended animation? They're alive?
Then he said sharply,
What sort of ship is it? Cargo?
No, sir, said Freddie. That's another problem. Bridges and I agree that it's a fighting ship, sir. There are rows of generators serving things that could only be weapons. By the way they're braced, there are tractor beams and pressor beams, and there are vacuum tubes that have grids but apparently work with cold cathodes. By the size of the cables that lead to them, those tubes handle amperages up in the thousands. You can figure that one out, sir. The skipper paced 2 steps this way and 2 steps that. The thing was stupendous, but his instructions were precise.
I'm under your orders, he said doggedly. What are you going to do?
I'm going to work myself to death, I suppose, said Freddie unhappily. And some other men with me. I want to go over that ship backwards, forwards, and sideways with scanners, and everything the scanners see photographed back on board here. I want men to work the scanners and technicians on board to direct them for their specialties. I want to get every rivet and coil in that whole ship on film before touching anything. The skipper said grudgingly,
That's not too foolish. Very well, Mr. Holmes. It will be done.
Thank you, said Freddie. He started to leave the bridge and stopped. The men to handle the scanners, he added, ought to be rather carefully picked. Imaginative men wouldn't do. The crew of that ship, they look horribly alive, and they aren't pretty. And uh, the plastic cases they're in are arranged to open from inside. That's another problem still, sir. He went on down. The skipper clasped his hands behind his back and began to pace the bridge furiously. The first object from beyond the stars was a spaceship. It had weapons the patrol had only vainly imagined. And he, a 2.5 striper, had to stand by and take orders for its investigation from a lieutenant junior grade just out of the academy. Because of politics. The skipper ground his teeth. Then Freddy's last comment suddenly had meaning. The plastic cases in which the alien's crew lay in suspended animation opened from the inside. From the inside. Cold sweat came out on the skipper's forehead as he realized the implication. Tractor and pressor beams, and the ship's fuel not quite gone, and the suspended animation cases opening from the inside. There was a slender coaxial cable connecting the two spacecraft now. They drifted in sunward together. The little cruiser was dwarfed by the alien giant. The sun was very far away, brighter than any star to be sure, and pouring out a fierce radiation, but still very far from a warming orb. All about were the small, illimitably distant stars, which were distant lights, which were stars. Oh no! The sun was very far away, brighter than any star to be sure, and pouring out a fierce radiation, but still very far from a warming orb. All about were the small, illimitably distant lights, which were stars. There was exactly one object in view which had an appreciable diameter. That was Jupiter, a new moon in shape 20 million miles sunward and 80 million miles farther along its orbit. The rest was emptiness. The spidery little spaceboat slid along the cable between the two craft. Spacesuited figures got out and clumped on magnetic-soled shoes to the airlock. They went in. Freddy came to the bridge. The skipper said hoarsely,
Mr. Holmes, I would like to make a request. You are, by orders of the board, in command of this ship until your investigation of the ship yonder is completed.
Freddy's face was haggard and worn. He said abstractedly, "Yes, sir. What is it?"
I would like, said the Arnina's skipper urgently, to send a complete report of your investigation so far. Since you are in command, I cannot do so without your permission.
"I would rather you didn't, sir," said Freddy. Tired as he was, his jaws clamped. "Frankly, sir, I think they'd cancel your present orders and issue others entirely." The skipper bit his lip. That was the idea. The scanners had sent back complete images of almost everything in the other ship now. Everything was recorded on film. The skipper had seen the monsters which were the crew of the extrasolar vessel, and the plastic cases in which they had slumbered for at least 2,000 years did open from the inside. That was what bothered him. They did open from the inside. The electronics technicians of the Arnina were going about in stilly rapture. Stilly rapture? Drawing diagrams for each other and contemplating the results with dazed appreciation. The gunnery officer was making scale detailed design drawings for weapons he had never hoped for, and waking up of nights to feel for those drawings and be sure that they were real. But the engineer officer was wringing his hands. He wanted to take the other ship's engines apart. They were so enormously smaller than the Arnina's drive, and yet they had driven a ship with 84 times the Arnina's mass, and he could not see how they could work. The alien ship was 10,000 years ahead of the Arnina. Its secrets were being funneled over to the little Earth ship at a rapid rate, but the cases holding its still living crew opened from the inside.
Nevertheless, Mr. Holmes, the skipper said feverishly, I must ask permission to send that report.
"But I am in command," said Freddy tiredly, "and I intend to stay in command. I will give you a written order forbidding you to make a report, sir. Disobedience will be mutiny." The skipper grew almost purple.
Do you realize, he demanded savagely, that if the crew of that ship is in suspended animation, and if their coffins or containers open only from the inside, do you realize that they expect to open them themselves?
"Yes, sir," said Freddy wearily. "Of course. Why not?"
Do you realize that cables from those containers lead to thermo batteries in the ship's outer plating? The monsters knew they couldn't survive without power, but they knew that in any other solar system they could get it. So they made sure they'd pass close to our sun with what power they dared to use, and went into suspended animation with a reserve of power to land on and thermo batteries that would waken them when it was time to set to work.
"Yes, sir," said Freddy as wearily as before. "They had courage, at any rate. But what would you do about that?"
I'd report it to headquarters, raged the skipper. I'd report that this is a warship capable of blasting the whole patrol out of the ether and smashing our planets. I'd say it was manned by monsters now fortunately helpless, but with fuel enough to maneuver to a landing. And I'd ask authority to take their coffins out of their ship and destroy them. Then
"I did something simpler," said Freddy. "I disconnected the thermo batteries. They can't revive. So I'm going to get a few hours' sleep, if you'll excuse me." He went to his own cabin and threw himself on his bunk. Men with scanners continued to examine every square inch of the monster derelict. They worked in spacesuits. To have filled the giant hull with air would practically have emptied the Arnina's tanks. A spacesuited man held a scanner before a curious roll of flexible substance, on which were inscribed symbols. His headphones brought instructions from the photo room. A record of some sort was being duplicated by photography. There were scanners at work in the storerooms, the crew's quarters, the gun mounts. So far, no single article had been moved from the giant stranger. That was Freddy's order. Every possible bit of information was being extracted from every possible object, but nothing had been taken away. Even chemical analysis was being done by scanner, using cold light oh my gosh, spectrography. Spectrography. I can't talk. I'm so sorry. Applied from the laboratory on the cruiser. And Freddy's unpopularity had not lessened. The engineer officer cursed him luridly. The stranger's engines now. They had been patched up after an explosion, and they were tantalizingly suggestive. But their working was unfathomable. The engineer officer wanted to get his hands on them. The physiochemical officer wanted to do some analysis with his own hands instead of by cold light spectrography over a scanner. I'm gonna trip over that word every time. And every man, from the lowest enlisted apprentice to the skipper himself, wanted to get hold of some artifact made by an alien, non-human race 10,000 years ahead of human civilization. So, Freddy was unpopular. But that was only part of his unhappiness. He felt that he had acted improperly. The ethical equations gave mathematical proof that probabilities and ethics are interlinked, so that final admirable results cannot be expected from unethical beginnings. Freddy had violated discipline, which is one sort of ethics, and after that, through his uncle, had interjected politics into patrol affairs, which was definitely a crime. By the equations, the probability of disastrous consequences was going to be enormous until corrective, ethically proper action was taken to cancel out the original crimes. And Freddy had been unable to devise such action. He felt, too, that the matter was urgent. He slept uneasily despite his fatigue, because there was something in the back of his mind which warned him stridently that disaster lay ahead. Freddy awoke, still unrefreshed, and stared dully at the ceiling over his head. He was trying discouragedly to envision a reasonable solution when there came a tap on his door. It was Bridges with a batch of papers.
"Here you are," he said cheerfully when Freddy opened to him. "Now we're all going to be happy."
Freddy took the extended sheets. "What's happened?" he asked. "Did the skipper send for fresh orders regardless, and I'm to go in the brig?" Bridges, grinning, pointed to the sheets of paper in Freddy's hand. They were from the physiochemical officer, who was equipped to do exact surveys on the lesser heavenly bodies. "Elements found in the alien vessel," was the heading of a list. Freddy scanned the list. No heavy elements, but the rest was familiar. There had been pure nitrogen in the fuel tank, he remembered, and the engineer officer was going quietly mad trying to understand how they had used nitrogen for atomic power. Freddy looked down into the bottom. Iron was the heaviest element present. "Why should this make everybody happy?" asked Freddy. Bridges pointed with his finger.
The familiar atomic
Oh, wait. The familiar atomic symbols had unfamiliar numerals by them. H3, Li5, GL8. He blinked. He saw N15, F18, S3435. Then he stared. Bridges grinned.
Try to figure what that ship's worth, he said happily. It's all over the Arnina. Prize money isn't allowed in the patrol, but 5% of salvage is. Hydrogen 3 has been detected on Earth, but never isolated. Lithium-5 doesn't exist on Earth, or glucidium-8, or nitrogen-15, or oxygen-17, or fluorine-18, or sulfur-34 or 35. The whole ship is made up of isotopes that simply don't exist in the solar system. And you know what pure isotopes sell for? The hull's practically pure iron 55. Pure iron 54 sells for 35 credits a gram. Talk about the lost treasures of Mars. For technical use only, the stripped hull of this stranger is worth 10 years' revenue of Earth government. Every man on the Arnina is rich for life. And you're popular.
Freddy did not smile. Nitrogen 15, he said slowly. That's what's in the remaining fuel tank. It goes into a queer little aluminum chamber we couldn't figure out, and from there into the drive tubes. I see. He was very pale. Bridges beamed.
100,000 tons of materials that simply don't exist on Earth. Pure isotopes, intact, not a contamination in a carload. My dear chap, I've come to like you, but you've been hated by everyone else. Now come out and bask in admiration and affection.
Freddy said, unheeding, I've been wondering what that aluminum chamber was for. It looked so infernally simple, and I couldn't see what it did.
Come out and have a drink, insisted Bridges joyously. Be lionized, make friends, and influence people.
No, said Freddy. He smiled mirthlessly. I'll be lynched later anyhow. I want to talk to the engineer officer. We want to get that ship navigating under its own power. It's too big to do anything with tow lines.
But nobody's figured out its engines, protested Bridges. Apparently, there's nothing but a tiny trickle of nitrogen through a silly chamber that does something to it, and then it flows through aluminum baffles into the drive tubes. It's too simple. How are you going to make a thing like that work?
I think, said Freddy, it's going to be horribly simple. That whole ship is made up of isotopes we don't have on Earth. No, it has aluminum and carbon. They're simple substances. Theirs and ours are just alike. But most of the rest. He was pale. He looked as if he were suffering. I'll get a couple of tanks made up of aluminum and filled with nitrogen. Plain air should do, and I'll want a gyro control. I'll want it made of aluminum too, with graphite bearings. He grinned mirthlessly at Bridges. Ever hear of the ethical equations, Bridges? You'd never expect them to suggest the answer to a space drive problem, would you? But that's just what they've done. I'll get the engineer officer to have those things made up. It's nice to have known you, Bridges. As Bridges went out, Freddie Holmes sat down, wetting his lips, to make sketches for the engineer officer to work from. And here on the side, we've got a little advertisement.
Stamped for death. They were only 2.5-penny orange stamps from the British Solomon Islands, but they were worth $20,000 to a certain collector. Gary Barton had to find out why, in order to prove his identity and his innocence in 2 murders. And that's when the Shadow stepped into one of the strangest assignments of his career in The 3 Stamps of Death. Read this thrilling tale in the June issue of The Shadow at all newsstands. What evil lurks in the hearts of men? Only the Shadow knows. Ha 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 ha!
Man, good stuff from a bygone era, I tell you what. If you can get a hold of watching some of the old Shadow serials, do it. Do yourself a solid. Those are a blast. The control room and the engine room of the monster ship were one. It was a huge globular chamber filled with apparatus of startlingly alien design. I don't know why it's startling. To Freddy, and to Bridges too now, there was not so much of monstrousness as at first. 8 days of familiarity. I'm losing my voice. 8 days of familiarity and knowledge of how they worked had made them seem almost normal. But still it was eerie to belt themselves before the instrument board with only their hand lamps for illumination, and cast a last glance at the aluminum replacements of parts that had been made on some planet of another sun. "If this works," said Freddie, and swallowed, "we're lucky. Here's the engine control. Cross your fingers, Bridges." The interior of the hulk was still airless. Freddie shifted a queerly shaped lever an infinitesimal trace. There was a slight surging movement of the whole vast hull. A faint murmuring came through the fabric of the monster ship to the soles of their spacesuit boots. Freddie wet his lips and touched another lever. "This should be lights." It was. Images formed on the queerly shaped screens. The whole interior of the ship glowed. And the whole creation had been so alien as somehow to be revolting in the harsh white light of the hand lamps the men had used. But now it was like a highly improbable fairy palace. The fact that all doors were circular and all passages round tubes was only pleasantly strange, in the many-colored glow of the ship's own lighting system. Freddie shook his head in his spacesuit helmet, as if to shake away drops of sweat on his forehead. "The next should be heat," he said more grimly than before. "We do not touch that. Oh, definitely. But we try the drive." The ship stirred. It swept forward in a swift, smooth acceleration that was invincibly convincing of power. That's a beautifully written phrase. The Arnina dwindled swiftly behind. And Freddie, with compressed lips, touched controls here and there, and the monstrous ship obeyed with the docility of a willing, well-trained animal. It swept back to clear sight of the Arnina.
"I would say," said Bridges in a shaking voice, "that it works. The patrol has nothing like this."
"No," said Freddie shortly. His voice sounded sick. "Not like this. It's a sweet ship. I'm going to hook in the gyro controls. They ought to work. The creatures who made this didn't use them. I don't know why, but they didn't." Then why would they have them at all? He cut off everything but the lights. He bent down and hooked in the compact little aluminum device which would control the flow of nitrogen to the port and starboard drive tubes. Freddie came back to the control board and threw in the drive once more. And the gyro control worked. It should. After all, the tool work of a space patrol machinist should be good. Freddie tested it thoroughly. He set it on a certain fine adjustment. He threw 3 switches. Then he picked up one tiny kit he had prepared. "Come on, come along," he said tiredly. "Our work's over. We go back to the Arnina, and I probably get lynched." Bridges, bewildered, followed him to the spidery little spaceboat. They cast off from the huge ship, now 3 miles or more from the Arnina, and untenanted save by its own monstrous crew in suspended animation. The Space Patrol cruiser shifted position to draw near and pick them up. And Freddie said hardly, "Remember the ethical equations, Bridges? I said they gave me the answer to that other ship's drive. If they were right, it couldn't have been anything else. Now I'm going to find out about something else." His space-gloved hands worked clumsily. From the tiny kit he spilled out a single, small object. He plopped it into something from a chest in the spaceboat. A mortar shell, as Bridges saw incredulously. He dropped that into the muzzle of a line mortar the spaceboat carried as a matter of course. He jerked the lanyard. The mortar flamed. Expanding gases beat at the spacesuits of the men. A tiny, glowing, crimson spark sped toward outer space. Seconds passed. 3, 4, 5. "Apparently I'm a fool," said Freddie, in the grimmest voice Bridges had ever heard. But then there was light. And such light! Where the dwindling red spark of a tracer mortar shell had sped toward infinitely distant stars, there was suddenly an explosion of such incredible violence as even the proving grounds of the Space Patrol had never known. There was no sound in empty space. There was no substance to be heated to incandescence other than that of a half-pound tracer shell. But there was a flare of blue-white light and a crash of such violent static that Bridges was deafened by it. Even through the glass of his helmet he felt a flash of savage heat. Then there was nothing.
"What was that?" said Bridges, shaken.
"The ethical equations," said Freddy. "Apparently I'm not the fool I thought." The Arnina slid up alongside the little spaceboat. Freddy did not alight. He moved the boat over to its cradle and plugged in his communicator set. He talked over that set with his helmet phone, not radiating a signal that Bridges could pick up. In 3 minutes or so, the great lock opened, and 4 spacesuited figures came out. One wore the crested 4 communication helmet which only the skipper of a cruiser wears when in command of a landing party. The newcomers to the outside of the Arnina's hull crowded into the little spaceboat. Freddy's voice sounded again in the headphones, grim and cold. "I've some more shells, sir. They're tracer shells which have been in the workboat for 8 days. They're not quite as cold as the ship yonder. That's 2,000 years to cool off. That's had 2,000 years to cool off, but they're cold. I figure they're not over 8 or 10 degrees absolute. And here are the bits of material from the other ship. You can touch them. Our spacesuits are as nearly non-conductive of heat as anything could be. You won't warm them if you hold them in your hand." The skipper, Bridges could see him, looked at the scraps of metal Freddy held out to him. They were morsels of iron and other material from the alien ship. By the cold glare of a handlight, the skipper thrust one into the threaded hollow of the nose of a mortar shell, into which a line end was screwed when a line is to be thrown. The skipper himself dropped in the mortar shell and fired it. Again a racing, receding speck of red in emptiness, and a second, terrible, atomic blast. The skipper's voice in the headphones.
How much more of the stuff did you bring away?
3 more pieces, sir, said Freddy's voice, very steady now. You see how it happens, sir. They're isotopes we don't have on Earth. And we don't have them because in contact with other isotopes at normal temperatures, they're unstable. They go off. Here we dropped them into the mortar shells and nothing happened, because both isotopes were cold, down to the temperature of liquid helium, or nearly. But there's a tracer compound in the shells, and it burns as they fly away. The shell grows warm. And when either isotope, in contact with the other, is as warm as, say, liquid hydrogen, why, they destroy each other. The ship yonder is of the same material. Its mass is about 100,000 tons. Except for the aluminum and maybe 1 or 2 other elements that are also non-isotopic, and the same in both ships, every bit of that ship will blast off if it comes in contact with matter from this solar system above 10 or 12 degrees absolute.
Shoot the other samples away, said the skipper harshly. We want to be sure.
There were 3 violent puffs of gases expanding into empty space. There were 3 incredible blue-white flames in the void. There was silence. Then,
"That thing has to be destroyed," said the skipper heavily. "We couldn't set it down anywhere, and its crew might wake up anyhow at any moment. We haven't anything that could fight it, and if it tried to land on Earth—"
the alien monster, drifting aimlessly in the void, suddenly moved. Thin flames came from the gill-like openings at the bow. Then one side jetted more strongly. It swung about, steadied, and swept forward with a terrifying smooth acceleration. It built up speed vastly more swiftly than any Earth ship could possibly do. It dwindled to a speck. It vanished in empty space. but it was not bound inward toward the sun. It was not headed for the plainly visible half-moon disk of Jupiter, now barely 70 million miles away. It headed out toward the stars. "I wasn't sure until a few minutes ago," said Freddie Holmes unsteadily, "but by the ethical equations, something like that was probable. I couldn't make certain until we'd gotten everything possible from it, and until I had everything arranged. But I was worried from the first. The ethical equations made it pretty certain that if we did the wrong thing, we'd suffer for it. And by we, I mean the whole Earth, because any visitor from beyond the stars would be bound to affect the whole human race." His voice wavered a little. "It was hard to figure out what we should do, what we ought to do. If one of our ships had been in the same fix, though, we'd have hoped for friendliness. We'd hoped for fuel, maybe, and help in starting back home. But this ship was a warship, and we'd have been helpless to fight it. It would have been hard to be friendly. Yet, according to the ethical equations, if we wanted our first contact with an alien civilization to be of benefit to us, it was up to us to get it started back home with plenty of fuel."
You mean, said the skipper incredulously, you mean you.
"Its engines use nitrogen," said Freddie. "It runs nitrogen 15 into a little gadget we know how to make now. It's very simple, but it's a sort of atom smasher. It turns nitrogen 15 into nitrogen 14 and hydrogen. I think we can make use of that for ourselves. Nitrogen 14 is the kind we have. It can be handled in aluminum pipes and tanks, because there's only one aluminum, which is stable under all conditions. But when it hits the alien isotopes in the drive tubes, it breaks down." He took a deep breath. "I gave them a double aluminum tank of nitrogen and bypassed their atom smasher. Nitrogen 14 goes into their drive tubes, and they drive. And I figured back their orbit and set a gyro to head them back for their own solar system for as long as the first tank of nitrogen holds out. They'll make it out of the sun's gravitational field on that, anyhow. And I reconnected their thermo batteries. When they start to wake up, they'll see the gyro and know that somebody gave it to them. The double tank is like their own, and they'll realize they have a fresh supply of fuel to land with. It may be 1,000 years before they're back home, but when they get there, they'll know we're friendly and not afraid of them. And meanwhile, we've got all their gadgets to work on and work with." Freddie was silent. The little spaceboat clung to the side of the Arnina, oh my gosh, yeah, which with its drive off was now drifting in sunward past the orbit of Jupiter.
It is very rare, said the skipper ungraciously, that a superior officer in the patrol apologizes to an inferior. But I apologize to you, Mr. Holmes, for thinking you a fool. And when I think that I, and certainly every other patrol officer of experience, would have thought of nothing but setting that ship down at Patrol Base for study, and when I think what an atomic explosion of 100,000 tons of matter would have done to Earth, I apologize a second time."
Freddie said uncomfortably, "If there are to be any apologies made, sir, I guess I've got to make them. Every man on the Arnina has figured he's rich, and I've sent it all back where it came from. But you see, sir, the ethical equations—" When Freddie's resignation went in with the report of his investigation of the alien vessel, it was returned marked "Not accepted." And Freddie was ordered to report to a tiny, hard-worked space can on which a junior space patrol officer normally gets his ears pinned back and learns his work the hard way. And Freddie was happy, because he wanted to be a space patrol officer more than he wanted anything else in the world. His uncle was satisfied too, because he wanted Freddie to be content, and because certain space admirals truculently told him that Freddie was needed in the patrol and would get all the consideration and promotion he needed without any politicians butting in. And the Space Patrol was happy because it had a lot of new gadgets to work with, which were going to make it a force able not only to look after interplanetary traffic, but defend it if necessary. And, for that matter, the ethical equations were satisfied. The end. And that was The Ethical Equations by Murray Leinster from the June 1945 issue of Astounding Science Fiction. There is another short story in here somewhere. Yeah, it's The Golden Journey, right after a shortish article on engineering and a shortish article on, quote, brass tacks, unquote, which looks like a letter to the editor of some kind with a lot of math. And I'll save this this advertisement for next time. In any case, thanks for tuning in. I hope you enjoyed. I realize I was mangling a lot of it, partly because I'm tired and partly because the font was faded and partly I have no excuses. Uh, so I do try to do this every week live at noon Eastern time. Uh, every Friday, where I read short stories and indeed entire novels aloud. I've got probably just one more reading from this issue of Astounding Science Fiction. Let's see here, real quick. Including this particularly long short story. And then some advertisements at the back, and that's basically it. Including those two articles. I apologize for the strobing lights. As I cycle backwards here to the page where I need to be. I do other streams throughout the week. I have a Mecha Mondays stream where I do something giant robot related or mecha adjacent. I also have a Warframe Wednesdays stream where I do some Warframe for a couple hours. And then, of course, this, Free Read Fridays. I also have it all archived on my YouTube channel, now into their proper playlists for the most part. So that should be good for all. I could probably stand to do a lot more organization there, but it's good enough at the moment. But yeah, after next week, I will be doing some short stories. Well, a short story and a presentation. The presentation I will not be narrating because it's already narrated for me. The short story I will be narrating. The short story is The Colonel, by Peter Watts, and the presentation is also by Peter Watts. And those, strictly speaking, will be a little premature, but will give reasonable grounding to the book I'll be reading afterwards, Echopraxia, by, of course, Peter Watts, which is the sequel to Blind Sight, which I had read aloud last year around this time, or 2 years ago, maybe. I don't remember when I read that, but I did it for this stream. It's archived properly, thank goodness. Echopraxy is really cool, like Blind Sight is. It's a bit different though, and I hope people enjoy that. I know I'm enjoying my reread of it currently, and I'm sure I'll enjoy reading it aloud. There's a lot of cool stuff to read there. Watts has a particularly punchy writing style that hits you right in the amygdala, right in the gut as well. Really, he doesn't have a huge body of work, but what he does have is I consider fairly worthwhile. Some people are don't like him very much for a multitude of reasons, and those are probably valid. Um, but not writing exciting fiction is not one of those things. He's very good at that. Alrighty, I gotta call it a day. I hope you people enjoyed, and I'll see you next time with any luck. See you later.